research out of Sherwood Park, just outside of Sherwood Park. And he had his PhD in ecology from the University of Alberta in 1988, and he's studied the ecosystems across Canada since then, and he's mainly interested in ecosystem changes and investigating those. And that's what he's here to talk to us about tonight. And you can see from the title, it's a familiar subject. And as I mentioned, there may be a few pop quizzes, so please pay attention. Kevin?
Thank you, Wayne. We will have a fairly long talk, so I'd like to sort of break it up in the middle so you don't get an information overload. What I'd like to do tonight is look at a number of recent studies and try to bring some science to the debate, because there's a lot said about the oil sands or the tar sands in Alberta and indeed across the world, but there's not often a lot of facts being brought to bear. So that's what I'm going to try to do for you tonight. So we'll first have a little background in context, then we'll talk about open pit mining, have a nap, which will be needed at that point. Then we'll talk about in situ issues and human health concerns, some new studies that have just come out in the last couple of months, and then summary and conclusion. Okay, so a little background and context. Ooh, that's hard to read here. Presently, there's no comprehensive peer-reviewed assessments of the impacts of tar sands development, in spite of a lot of money being spent. The Canadian Environmental Assessment Agency, CEMA, the Department of Fisheries and Oceans, RAMP, Environment Canada, Alberta Environment. If I were to sum up the participation of all of those agencies, I would say that right now we're looking at a failure to monitor and to understand and to control the cumulative effects of what's happening. And there's also been a failure to enforce the Fisheries Act, Migratory Birds Convention Act, and APIA, Environmental Protection and Enhancement Act. Just to give you a little idea of what's happened over time, back in the 70s, you look at these downward trends here. Let's just focus on the total number of observations. This is the back in the 70s, Alberta had one of the world's best environmental monitoring capabilities, state-of-the-art. And over time, especially after Ralph Klein came on board, there's been a continual loss of the ability to monitor and understand what is happening. And just for a comparison, this is the total aerial footprint of the tar sands over the same time scale. So as this industry has expanded exponentially, we have lost the ability in terms of having publicly available information, data that is held by you, by me, and by our elected representatives. It's now mostly privately held, and that's not a good thing. Let's talk a little bit about the terminology. Oil sands versus tar sands. There's a lot of funny notions about those terms. Back in the old days, it used to be called tar sands. In fact, if you go up into the museum in Fort McMurray, you'll see some displays here. So, you know, even people from Fort McMurray, all over Alberta, we all used to call it the tar sands. And still today, the U.S. Department of the Environment calls it the tar sands. So it's not a bunch of environmentalists are the only people calling it tar sands. However, to be correct, they're not tar sands, nor are they oil sands. I use tar sands just because it's a short term and it has it sort of conveys what the material looks like. However, to be correct, they're actually bitumen sands, which are sand grains that are enveloped by a film of water, which is in turn enveloped by a film of bitumen. What is bitumen? It's various complex mixtures of high molecular weight hydrocarbons. It's usually brown or black. It occurs naturally. Now, tar is formed by destructive distillation. So when you burn something and you get a tarry deposit, that is truly what tar is. So when we call tar sands, it's not completely correct in terms of physical science, but as I said, it has the sound of sense to it. Natural bitumen has a very high viscosity. It tends to be immobile in the reservoir. In other words, you need to do things to get it out of the ground, and it requires upgrading. Now, we all know that the lower Athabasca region has contaminants that come from both natural sources and human activities. The question is, to what extent do human activities increase the level of contaminants above the background? Now, the Alberta government position has been consistent for years in spite of facts to the contrary. So if you were to ask Alberta Environment today, they would tell you things such as there are no detectable changes in water quality in the Athabasca River and in the regional lakes due to mining. None, which is false. Industry is prohibited from discharging untreated processed water from oil sands projects into the Athabasca River, is what they will tell you. However, the truth is something else. Extensive testing has shown no signs of elevated risks for people living downstream. Demonstrably false. Further, they will say that the government ensures a healthy environment. Stringent testing has consistently shown there have been no increases in contaminants as development has progressed. False. The contaminant sources in the area are natural, unquote. These statements are all false. Now let's look at where these contaminants are coming from. It comes from a variety of sources, some of which might be a little surprising. First of all, you have permitted licensed discharges to air, water, and to land. Each company has a license to discharge so much into air and land and water per year. There's seepage from the tailings ponds that escapes collection. Evaporation from the tailings ponds, it's a very big issue that has not received much attention until recently. Leaks from pipelines. There are then spills of bitumen, oil, wastewater, and chemicals, quite common. Stack emissions, obviously. A big factor is wind-blown pollution, and wind-blown dust can come from various sources, one of which is coke piles. Dry tailings, as they desiccate, they're picked up by the wind and blown in the air. And then there's also the dust itself that the trucks are driving over, or they're in the pits as the machinery is working them, and winds pick them up and deposit them across the landscape. Outgassing from the open pits themselves. And finally, you have a variety of activities such as transportation, construction, and dewatering that all lead to discharges to the environment. So in one study, we asked the question, to what degree are industrial activities detectable in northeastern Alberta? So we posed the question in 4 ways. We asked, are the present levels of contaminants, regardless of whether they're natural or human in origin, are they presently posing an ecosystem or human health concern? Secondly, if we hold time constant and we compare at the same time upstream and downstream, do we see an effect? Do we see a change in concentration? Thirdly, if we look at the same site over and over again over time, is there a change? And fourthly, are there documented incidents of industrial pollution or landscape degradation? So let's look at some of the results. First, we'll look at upstream, downstream comparisons at the same time. In this one set of data, we looked at PAH is polycyclic aromatic hydrocarbons, which is a complex class of organic pollutants common to bitumen. And we looked at a site on the Muskeg River immediately upstream and immediately downstream of development. And this graph here, we are comparing the concentration of 28 different PAH types, different species of PAHs. And if that point were to fall on the line, there would be no effect. If the point were to fall below the line, it would mean that the concentration actually went decreased downstream. If it's above the line, then the concentrations of these materials are increasing as we go downstream. This is a logarithmic scale. So if we were to summarize this result here, and we compare for these compounds how much they're changing upstream or downstream, we get a mean change of about 700%. So in other words, the average compound is increasing by a factor of 7 when we go from an upstream site to a downstream site for these PAHs that are in the Muskeg River. That's fairly unequivocal evidence. New study that just came out, I'll talk to you, just came out a few weeks ago, corroborates this result. Okay, upstream, downstream comparison. Again, this time we'll compare sites within the Athabasca River, upstream and downstream of Tar Island Pond 1. Here we looked at 24 different metals that are in the pore water of the Athabasca River, so the water that sits beneath all the riverbed between the silt and sand grains. That's called pore water. And we compare sites immediately upstream and downstream, 24 different analytes. 19 of them decreased downstream of the pond, while 5 decreased. The mean increase downstream was 400%. The primary concerns are ammonia, arsenic, iron, and zinc. 9 of these chemicals increased 3 or more fold, so more than 300% downstream of the pond. None decreased to that extent. The ones that were the largest concerns: ammonia, aluminum, very high levels of aluminum, antimony, arsenic, copper, lead, strontium, uranium, and zinc. Clear evidence that Tar Island Pond 1 leaks. A little bit more on tailings ponds leaks. No scientist, no engineer will ever tell you tailings ponds don't leak. They all leak. The only people who say they don't leak are people from the government or public relations people. The truth is that they all leak. The question is how much they leak. Alberta government technical staff must lie awake at night because they know a lot of what's going on. If you go into the records, you can see that they're advising Syncrude that they hope that when they put a new soil bentonite wall in, that they're going to eliminate their seepage. We know that on the Suncor lease, the place called natural wetland has elevated hydrocarbons, naphthenic acids, and salinity, directly traceable to seepage of tailings through the containment dike. Tailings leaks are pretty well studied at Mildred Lake. Here on the Syncrude lease, all of these wells here allow us to look at the concentrations of these various chemicals that are in the groundwater. Alberta Environment knows that Syncrude's mitigation wells are not working and that there is a very large contaminated plume of groundwater heading into the Athabasca River. Another way to think about tailings ponds leaks is if you know how much tailings in terms of volume is being dumped into the ponds in a unit of time, and you know the area of the ponds, you can determine how much they should increase in elevation. If you do this sort of back of the envelope calculation, in a given year, if you correct for local precipitation and evaporation from the pond, each pond should increase in elevation by about 1.6 to 5.2 meters, 5 to 17 feet, if there's no recycling of cap water. Now that throws a large variable in. For example, Shell Albion does a lot of recycling of their cap water. But the bottom line is simply that if the tailings ponds didn't leak, they would rapidly overflow. They don't leak. They don't rapidly overflow, even with the millions of liters that are being dumped into them. And so that's just sort of a common sense way of thinking about them. If you look at a satellite image of Tar Island Pond 1 and 1A, this one is in 1993, this was in 1999. 6 years later, if it's not leaking and you're dumping hundreds of millions of liters in, this should be a larger water body, but it's actually shrunken slightly over that period. So, it's pretty obvious. In fact, Tar Island Pond 1 is the best studied of all of the ponds, and I'll tell you a little bit more about that later. At Mildred Lake, one of the interesting things about the tailings pond is it was recently studied by a team of researchers from the U of A, and they determined that the bacteria that lived within the tailings ponds have changed recently, and they're now producing very large volumes of methane due to their working on the hydrocarbons. It amounts to, in the case of Mildred Lake, the equivalent methane production of 500,000 cattle from just Mildred Lake settling basin. So, methane and other volatile organic compounds coming off these ponds is a very large and significant source of air pollution that is often neglected. Okay, again, just more documentation as to what the scientists and the engineers know and admit, but the government doesn't. For example, I was just at a meeting with Shell Albion last month, and I had a very frank discussion with the engineers, and they said, we have never said that our tailings ponds don't leak. They leak. Everybody knows that. Sort of don't look at us. It's the government that keeps saying this, which I thought was kind of interesting. Environmental Defense did the most definitive study to date of the leakage of tailings aggregate from all the ponds, and they found that daily production of tailings is about 1.8 billion liters. That's per day. Since 1968, roughly 5.5 trillion liters of tailings have been produced. In 2007, they estimate that the tailings ponds escaped leakage, that is, it got away from collection wells, about 11 million liters per day, which is about 4 billion liters per year. Now, if you think about how much tailings are produced and how much escape, it's actually pretty good. Their engineers are doing a pretty good job. For every 160 liters of tailings that are put into the ponds, about 1 is escaping. That's not bad, but the problem is we're dealing with such tremendous volumes of tailings that this ratio ends up being a very large number, such as 34 billion liters of tailings to date. Okay, let's look at another way of comparing how the system is changing over time. We're looking at the same sites. So these are all sites from the Athabasca River Delta, well downstream, since 1999 to the most recent data that are available. This is the total amount of alkylated PAHs that are in the sediment. This is parts per million, basically milligrams per kilogram. And this is a regression here. So there's a very clear trend over time. Now, one of the things, if you do a little statistics here, we find that the concentration of PAHs is indeed rising over time, but it's also correlated to about the same degree with the amount of water going down the river, the Q. So in other words, in years in which the Athabasca is flowing above average, it will tend to carry far more PAHs down the river and deposit them in the delta. So both flow rates and time, meaning development, are involved. Okay, let's look at the trend. Again, we're going to look at a totally different set of data here. This is the concentration of mercury in the tissue of walleye. Now for here, I went back into the old AOSERP, the Alberta Oil Sands Environmental Research Program. Very good research program that unfortunately was discontinued many years ago. And we look at what they were finding back in 1976, what they were finding in the early 90s, and what was found most recently. Again, it's a very clear increasing trend of mercury in the walleye. Now these, you may ask yourself, well, is this an environmentally significant amount of mercury? You bet it is. It's about 8 to 10 times what you would want to be consuming as a limit. So by 2006, for these data, all of the walleye and all of the female whitefish, I don't have the whitefish here, but all of the female whitefish and 90% of the male whitefish exceeded the subsistence fisher consumption guidelines. Just recently, a few weeks ago, I got a letter from Minister Renner where he told me no increases in contaminants as oil sands development has progressed, unquote. Apparently, he's not aware of these data. Okay, another set of data, we'll look at how the footprint has changed over time. So all of these areas that are hatchered in red here are part of the industrial footprint that straddles the Athabasca River. As of spring 2008, 65,000 hectares have been converted from natural landscape to 12,058 hectares of tailings ponds and about 53,000 hectares of pits and facilities and infrastructure. Within that footprint, of course, most of the native biota has been lost. The biggest losses have been to coniferous forest and to deciduous forest. Between those 1992 and 2008, the area of tailings ponds grew by 422%, and mine pits, facilities, and infrastructure grew by a similar amount. Now, if you look at these various habitat types, and you go back to the literature and you ask yourself, if we lose this amount of habitat, how many birds do we lose forever? And it turns out that somewhere between 58 to 402,000 birds have been lost because their habitat has been lost from the regional population. And those losses are independent of the birds that die due to tailings exposure, which we'll get into in a few minutes. Now, one question you may ask yourself is, why would we find increasing levels of mercury in the fishes? One of the most plausible explanations for that is as a landscape is increasingly disturbed, it tends to leak mercury. In particular, wetlands that have been disturbed tend to lose their mercury to surface water, and of course that gets into the food chain. It's been shown in Ontario that mercury in boreal lakes is correlated very clearly with the extent of watershed disturbance. The more you disturb the watershed, the higher the mercury levels in the lakes. If we look at the amount of mercury in other fishes that have been recently studied in lower Athabasca and in Lake Athabasca, these amounts of mercury are extremely high. The subsistence fisher guideline is 0.049 milligrams per kilogram. So these values in this case would be over 100 times what would be considered safe to eat at subsistence fisher level. So all of those fishes have become unsafe to eat. Pollution incidents. One other project we did recently is we went into Alberta Environment Records and we gathered up the documentation from incidents that have been recorded in their database from all of the companies over time. And we found that over about a 10-year period, there were 7,000 incidents from the companies in the area. The most common ones being flaring, hydrogen sulfide exceedances, sulfur dioxide exceedances, sulfur releases, failures to report, excessive downtime for equipment and monitoring devices, and then various spills and water quality exceedances. Now, spills and incidents have been with us for a very long time indeed. One of the most interesting cases was back in 1970 when a pipeline at Suncor broke and spilled 3 million liters directly into the Athabasca River. It was then observed in around Fort Chip and in the Delta and Lake Athabasca within about a week. And so this is an air photo here of the oil that's washing up on shore around the south shore of Lake Athabasca. You know, given the passage of time, we can perhaps take a fairly lenient attitude towards their lack of action here, but if you look at the documentation, basically what happened was the oil spilled into the river and they didn't do anything. They just let it go, thinking, well, nature will take care of it. Okay, so now let's focus on another set of information. Discharge from Suncor. Now, Suncor, I'm going to give some credit to right now because Suncor, in my experience, has been the most helpful and forthcoming of the companies in terms of actually giving information when I ask for it. Unlike Syncrude, that seems to think that they are above the law and above the public. So let's just put a little bit of perspective here into what Suncor is putting into the river. In September 2007, from their wastewater pond system, these are the wastewater ponds here. Now bear in mind, wastewater ponds are completely different from tailings ponds. This is the dike of Tar Island Pond 1 here. Different kind of water. This is the water that comes from processing within the plant. So the wastewater pond system is sitting here, unfortunately, right along the river. It's got a different chemical makeup than the tailings. It's very high in salt. It does have a fair bit of oil in it. It's got some heavy metals, etc. It's not nice stuff, but it's probably less toxic than the tailings. But having said all that, about 1 million liters was discharged by human error into the river, and eventually, due to a long story, that information got to the people in Fort Chip. Suncor had a meeting with the people in Fort Chip. They promised it would never happen again. It happened again. Within a year, it happened again. Okay, so that's 1 million liters.
What's the year? I just can't read it.
I'm sorry, 2007.
Thanks.
So that was 1 million liters. It sounds like a lot. But let's look at how much Tar Island Pond 1 leaks per day. 2 billion liters into groundwater connected to the Athabasca River per year. That sounds like a lot. But if we look at the licensed discharge, what they're allowed to produce from this outfall here into the Athabasca River, it's 12 billion liters per year. That's 6 times the seepage from Tar Island Pond 1 and 12,000 times this spill. So Suncor went to Fort Chip and apologized for spilling 1 million liters because they were caught. But for some reason they're not talking about they're actually licensed to put 12,000 times that amount into the river. Okay, air pollution. Air pollution is probably, in my experience and looking at the data, the emerging issue in terms of the industry up there because it has effects in so many ways. So let's just look at what the most recent data tell us. If we look at Syncrude, Mildred Lake, and Suncor PM 2.5 is very fine particulate matter. It's the most dangerous material to breathe in because it's small enough to get in deep into your lungs and lodge in the villi and cause detrimental health effects. This is the number of tons that Syncrude is producing versus Suncor. And these little parentheses here are really the important part. That number means that Syncrude Mildred Lake is the largest producer of these fine particulates in Alberta, the second largest source of these pollutants in Canada. So Syncrude has an amazing record here. They're first, third, second within Alberta. In other words, this single facility is probably the largest single polluter in Canada. If you look at their ratings, they're second largest, third largest, sixth, fourth, third, and third of all the industry facilities in Canada. These are all compounds that have effects on ecosystems and effects on wildlife and effects on people. Suncor is the largest producer in Canada of volatile organic compounds. So things like H2S, benzene, etc., things that are evaporating off the ponds primarily. So bottom line, if you just dig up the information, it's quite obvious that we're looking at facilities, and these are just two of the major facilities there, are nationally significant polluters. I'm sorry, I can't really read that. It's too bright. Can anybody see that?
Transition from land to water, I think? Or?
I'll just put it all up here and then I'll talk about it.
Oh, from bad to worse.
Yeah, it's from bad to worse. In other words, if you were to talk to, that's a little better. If you were to talk to the Alberta government officials, they will tell you that the air quality is under control, that don't worry, there's no trends. That's a complete falsehood. None of the air quality scientists that I've talked to would say that. If you just, I mean, these data are directly from Alberta Environment Reports. So if we look at from 1999 to 2006, so just a 7-year period, sulfur dioxide, depending on what the study site is, up 2 to 62%, 24% at Fort McKay. Peak SO2 up 8 to 122%. Peak PM 2.5 up 17 to 79%. By 2010, that's this year, the fine particulates releases are going to be around 11,200 tons per year, which is an 87% increase from just 5 years ago. Similarly, oxides of sulfur up 38% in the same period. Volatile organic compounds up 119%. Nitrous oxides up 78%. So we have a bad situation as of 5 to 10 years ago, and it's rapidly getting worse. Now, again, the same letter I just received from Minister Renner, he tells me, quote, there's no change in the long-term air quality for fine particulate matter and sulfur dioxide, yet his own department is saying the opposite. So there's a disconnect. It's a false statement. Okay, lichens, another good source of information. There have been several good studies done over time. Recently, they looked at lichens in a large number of study areas spread across the region, and they correlated the amount of metal that was growing in the thallus of the lichen, and they matched those. They actually, the lichens were very good samplers because by their air modeling, they were matching the patterns that they were predicting would be precipitating out of the atmosphere. The growth impairment and the actual tissue damage increased exponentially as the facilities were more proximal. And they also found with decreased distance, so in other words, as you approach the main plants, the amounts of sulfur, nitrogen, chromium, iron, nickel, and vanadium, large increases in the lichen tissue. So the lichens are actually very useful laboratory tools to tell us that we have a serious air pollution situation. Okay, fish abnormalities is another issue that people are concerned about. First of all, you need to realize that not all abnormalities of fishes are due to pollution. It can come from a variety of sources. For example, injury or disease, unusual water quality, toxic algal blooms can all lead to reproductive difficulties, which will lead to birth defects in their young. So if you have abnormally high water temperatures, you can see the next generation will have an increased rate of abnormalities. So not all fish abnormalities are directly traceable to pollution. However, this has been fairly well studied, and they've shown that if you take the bitumen and wastewater pond sediments and you expose experimental animals, in this case fathead minnows, to environmentally relevant concentrations, there are increases in mortality, structural malformations, and reduced size in the young. Experimental evidence. The larval abnormalities include swelling, edemas, hemorrhages, and spinal malformations are particularly common. Now, we also know that the level of PAHs in the sediment of the Athabasca River is about twice that known to induce liver cancers in fishes. So that's indirect evidence. Now, here's a cautionary note. This so-called two-jawed goldeye is not a deformed fish. This image circled around the internet, and unfortunately, it was based on a poor identification. This is actually, this thing that looks like the second jaw is actually the tongue. The tongue of a goldeye is toothed, and when they die, quite often the ligaments that hold the tongue in place will relax, and the tongue falls down, and it makes it look like a double jaw. But if you look down into the mouth, you can see the floor of the mouth is gone. I've physically examined this fish in the museum at the University of Alberta with an ichthyologist. No question, it's not a deformed fish. So it's very important, if you're concerned, to really check your facts before you start publishing things. Okay, now these walleye here, or pickerel, are deformed. They have a lot of deformities. You can see here lesions, external tumors, misformed cranium, bulging eyes, scoliosis, mal-shaped fins. These fishes are highly deformed. If we look at the scientific evidence that have been gathered over the years, and we talk to the local fishermen who are fishing over many years, the data indicate that the rates of the fish normalities are probably higher than expected, may be increasing, and may be related to declines in water quality. Okay, bird deaths at tailings ponds, this is a timely issue. Another data set we looked at was to go back and dig out scientific studies that have been done over the years where they actually counted the number of birds that were dying at tailings ponds at Syncrude and Suncor and Shell. And then I looked at the data in a few different ways to scale up to the entire size of the tailings ponds. And ignoring this here for a moment, depending on the data set, we get a range of annual mortality, that's each and every year, of about 458 to 5,037 birds. So all of this, this controversy with Syncrude now with the 1,600 ducks, and Syncrude claiming it's never happened before, and it's just an unusual, rare event. That is a falsehood. It happens year in, year out. It may be 5 birds here, 50 birds here, 100 birds here, 1,000 birds here, but it's a constant process that has been happening for decades. And it's been very well hidden because these facilities are basically private. We can't go there and sit down and observe the birds dying. So we have to depend on other people and limited scientific data. Another source of information here is each of the companies has to report each year in their annual report how many birds they have found dead. And these reports are basically ad hoc. So an employee will be driving along and will see a dead duck on the road, and he may or may not report it. That is what the government and the industry is considering to be reliable data. So they're agreeing to an annual mortality of all the tailings ponds of about 69 birds per year, which is ludicrous. So there really is no systematic and scientifically robust bird mortality monitoring. It's only by putting together fragmentary evidence that we can come up with an estimate of how many birds are dying. This is a golden eye that died, a shoveler, a Bonaparte skull that was in the process of dying. These are 4 scout that were swimming around in a tailings pond at Albion. Don't ask me how I got it. Okay, another study that recently came out, Ronconi and St. Clair studied the effectiveness of deterrence. So you've probably heard about deterrence that the companies are using, where they're shooting propane cannons. They have effigies that are scaring the birds. They have radar, which senses a flock coming and then causes the propane cannons to fire, or to have predator calls or distress calls, etc. All of these are called deterrents that are aimed at minimizing the number of birds landing in a pond. So the first thing they did was they studied this, and they found that there was a reduction in landing probability, particularly for shorebirds, things like sandpipers and peeps and things, in the radar-activated system, for example, at Shell, relative to the control. So, in other words, no effort. However, here's where it gets interesting. There's no significant difference in landing probability, in other words, deterrence effect, between the radar-activated and the industry standard. And here's where it gets even more worrisome. If you look at a control pond, so we have no deterrence here, it's just a tailings pond. For every 100 ducks that would land in that pond, 38 ducks will land in the presence of industry standard deterrence. So even if you have all of your deterrents in place, 38 ducks will still land for every 100 ducks that would land in an unprotected pond, and 69 shorebirds, as opposed to ducks, will land. Let's compare how the radar works. Again, the radar is supposedly the state of the art. For every 100 ducks that would land in an unprotected pond, 53 ducks are still landing, and 20 shorebirds. So it works better with shorebirds, but the bottom line is that no deterrent provides full protection, in spite of what industry will tell you. So the obvious conclusion is that hundreds to thousands of birds will die each and every year at the tailings ponds until tailings ponds are phased out. Another data set. I FOIP'd the government, they just love me. I FOIP'd them for mammal mortality data, and it turned out, surprisingly, that there is no mortality monitoring program. So they actually had to generate these data from scratch. It took them 8 months to make a spreadsheet, which they finally released to me. So for the 3 companies, and only those companies that have tailings ponds are required to do this. If you combine the 3 companies and their years of operation, they're telling us that 162 mammals died in 22 years, including 1 marten, 1 redback bull, and 1 weasel. Do I need to make a comment? Yeah. So, ad hoc, in other words, these sort of observations that are done by Pete, when he's having his lunch and notices there's a dead coyote by the road, are gross underestimates of the actual mortality. Okay, let's take a break for about maybe 5